Is Albert Einstein a scam? I just asked a question that is heretical. Einstein is the #1 smart person figure. Who are we to challenge his brilliance, right? In my conceptual physics textbook, it says that under relativity, if it doesn't make any sense to you, don't worry. It makes no sense to virtually anybody. Now that's awfully bizarre. We're supposed to just accept this idea that makes no sense to anybody? No. Okay, so this is like the detective situation when everybody tells the detective, don't look in that closet. That closet over there. You can look anywhere in the house, but don't open that closet there. Well, that's the first thing the detective wants to open and investigate. In fact, anytime a person challenges relativity, the very response you're always going to get is the same thing, and it's going to be, there's all this experimental evidence to confirm relativity, right? And yes, certain aspects of relativity I think are true, but that doesn't mean everything is true. It could be wrong about a whole bunch of things, right? So relativity is a package deal. It's kind of like religion, okay? So religion makes some correct claims. That doesn't mean the religion is correct as a whole. Okay, so I'm going to try to explain relative motion versus, I guess absolute motion would be what most of us think of. Okay, so let's say we're in outer space and there's these two comets here, right? Okay, and let's say we're sitting on one of these comets. Let's say we're right here. We're sitting on this comet, right? And now we see this other comet hurtling towards us. Okay? I guess what Einstein would argue here, okay, is that you don't actually know whether it's you who's moving towards them or whether it's them who's moving towards you, right? Let's say you were flying towards this comet, right? It would look exactly the same from your point of view as if this comet were flying towards you. Okay, good. No one would disagree with Einstein so far. But here is where it gets bizarre. Einstein says that all motion is relative. And there is no such thing as a universal frame of reference. So what does that mean exactly? Right? So in our minds, one of us is moving, okay? So, or possibly both. The comet still has a speed and we still have a speed, okay? We just can't measure the speed because we don't actually know whether we're the one moving or whether the comet's the one moving. Now suppose that we're flying towards a comet 100 kilometers an hour and the comet's stationary. And now we take the comet and remove it from the universe. We just scoop it out of the universe. What we would say is that we're still moving 100 kilometers an hour. Einstein would disagree. He would say that motion is relative, and since there's nothing to measure motion against, motion itself ceases to exist, and you're now stationary. All right, so the first thing that's really bizarre about this already is most of us imagine like the universe being some boundary, like let's say the computer screen's the universe. We have an x and y coordinate, and we define motion as a change in those x and y coordinates. If that x and y coordinate is shifting, we are in motion. And if that x and y coordinate is staying the same, we are not in motion, right? And it doesn't matter whether this object is moving around us or not, it's not going to affect us in any way, right? So Einstein does not agree with that term. And that's very bizarre because Einstein says he doesn't know if the universe is infinite. Well, in his model, the universe has to be infinite, all right? In order for this idea of relative motion to work, I think the universe has to be infinite. Otherwise, you're moving relative to space, right? If there's an end of the universe here and an end here, and your x and y coordinates changing, then clearly the walls of the universe are a universal frame of reference, right? And all motion is relative to the walls and boundaries of the universe. Now, in an infinite universe, Einstein's model can work, okay? Because if there is no walls in your universe and you go from here to here, there's still an infinite amount of space in this direction. There's an infinite amount of space in this direction, and this direction. So motion doesn't actually do anything, right? Moving doesn't actually do anything. It only has an effect if there's another object, right? You can only say your position has to be relative to another object. Okay, so the next effect of relativity is time dilation, okay? So what is time dilation? Time dilation is the idea that as something is moving faster relative to another object, time itself slows down, okay? It's not just our ability to measure time, time itself actually slows down. So let's say we have our rocket and it's flying 10,000 kilometers per hour. We launch it off the Earth and we do a big mission. Let's just say we fly it around the Earth a bunch of times at 10,000 kilometers an hour, right? For a whole bunch of years, let's say 50 years. What Einstein would argue is that the pilot, the people on the actual ship, are going to be younger, okay? Because time will slow down because the ship is moving fast relative to Earth. Okay, so that's the first thing that will happen. Therefore, the pilot will be younger when he gets back on Earth because time is passing slower inside that rocket ship. Well, that's pretty cool stuff, okay? That's really neat. So if we're flying in a rocket, we can actually slow down aging relative to the speed of people aging on Earth. Okay, here we go. So let's get to the twin paradox. Now, remember in Einstein's model, all motion is relative, all right? So this rocket is moving 10,000 kilometers an hour relative to the Earth, right? But if all motion is relative, you can also make the argument that the Earth is just moving 10,000 kilometers an hour away from the rocket. Its relative speed to the rocket is 10,000 kilometers an hour in the opposite direction. That is true. Einstein would say that's true. Any physicist would probably tell you that's right. All right. So then, shouldn't the Earth also experience an equal amount of time dilation? If relative speed is what causes time dilation, and the Earth is moving the same relative speed as the rocket in the opposite direction, shouldn't Earth also experience time dilation, and shouldn't the effects of time dilation cancel out? Because they're both moving 10,000 kilometers an hour, relatively speaking. Einstein says no, only the rocket will experience time dilation, the Earth will not. The pilot on the rocket will come back younger than the people on the Earth. There seems to be a very clear problem here. So, and this is where I think the religious thinking really comes in. And Einstein himself says in his book in philosophy, science without religion is lame. Okay, a lot of people say Einstein's an atheist. If you read his book, I think it's pretty clear he's not an atheist. And I think it's pretty clear he likes some sort of religious tendencies in his science. Okay, so I'm not certain about that, right? But I think that's what's going on here. Okay, I think that's a very likely scenario here. Okay, so the solution to this is what happens is when the rocket accelerates off the Earth, acceleration is the difference. Okay, so the difference is the Earth did not accelerate off the rocket. There's no boosters. There's no big boosters on the Earth blasting the Earth away from the rocket, right? There's boosters on the rocket blasting it away from the Earth. If acceleration does not cause time dilation, then you run into this thing called the twin paradox, where both things should experience time dilation, and Einstein's theory would be wrong. The obvious question should be, what experiments actually confirm that acceleration causes time dilation? And take a look at this. Very interesting. There's no experiments about this. So this, what would obviously be the demise of relativity, no one's ever taken the time to make an experiment to check in 100 and some years. And ChatGPT might be wrong. Maybe ask some physicists. Maybe there has been an experiment done to measure specifically acceleration. But ChatGPT is a pretty good science archive.
Okay, so it's been accepted that acceleration is one of the main resolutions to the twin paradox, even though it has zero supporting evidence, as far as I'm aware. And this is a very interesting study here. And this study, they delved quite a bit deeper into this than I did. And nowhere does it say in the theory of special relativity that your inertial frame of reference cannot be switched. And the second explanation that's commonly given of acceleration, which is what we were just talking about, that again is not in special relativity, and there's no discussion of that in the time dilation equation.
Well, to me, it seems like we have a closet full of blood, and we're telling a detective, don't look in the closet full of blood. You can look in any other closet. Now, if you read Einstein's book in Special Relativity, it says that if you understand a concept, you should be able to explain it as though you're talking to your grandmother. And I guess it's kind of a sexist statement. We're assuming that grandmothers are not physicists, right? We're supposed to be, in Einstein's time, women didn't really learn math and stuff like that. Well, I encourage any grandmother, specifically any grandmother who's not a physicist, to pick up Einstein's book in Special Relativity and then read it and tell me if they understand it. Tell me if it makes sense. They'll get to like maybe the first 4 pages and then they'll be totally lost. Okay, I think they'll get to the carousel example where they're dropping the ball, and then after that they're just, what is going on? So if Einstein, using Einstein's own litmus test, right, the grandma test, his ideas don't make sense to even physicists. Even in my conceptual physics textbook, the physicists don't understand his idea. Does Einstein understand his idea? And if Einstein doesn't understand his own idea, why should you believe it? I mean, he's the guy saying science without religion is lame. I don't think his ideas are very convincing. To me, it seems like a very sketchy foundation. And this is just touching on the basis of Einstein's models, okay? This is just one small aspect. You also have all this stuff about space-time. You have general relativity. I don't know if it was Einstein who said time is the fourth dimension, but you have stuff like that too. There's all these other ideas and bending space-time and all this. And